Okay, good morning, everyone. So our topic will be about solutions of first order ordinary differential equations. So the first method you're going to learn is the separation of variables or variable separable. Okay, so in this section or in this lesson, we will examine a subclass of linear and nonlinear first order equations. Okay, our objective here is to determine the solution of a first order ordinary differential equations. So if last time you have learned how to arrive at a differential equation and the technique that you have done is differentiation, in this lesson you are going to utilize anti-differentiation or integration to arrive at the solution of the given ordinary differential equation. Okay, so we will be focusing on first order equations. So let's consider this um, first order dy over dx equals the functions of x and y. And we can rewrite this form into m, a function of x and y, plus n, a function of x and y times dy over dx equal to 0. Or you can rewrite this into a differential format where m is the coefficient of dx and n is the coefficient of dy equal to 0. So as you can see, m here is a function of both x and y, or it may be a function of x only and both a function of x and y. And n here is a function of x and y. Okay, now for us to be able to solve the given dE or to find its solution, then dx should contain only pure function or variable x. dy should contain only coefficients that are a pure function of y. Okay, so it says here that if the given function, okay, ito na nga, we can be able to, transform or put this equation where dx has a function of both x and y, and dy has a coefficient with functions of both x and y. You can put it into this form where dx has a pure function of x as a coefficient and dy has a coefficient of a pure function of y equal to 0. Then this is a separable differential equation or a variable separable dE. Okay, because after this, your method or the technique is to integrate now each term. Okay, so you are now going to integrate after you have written the given equation to this format that you were able to separate the variables. Okay, there are many methods, techniques in how you can solve a differential equation. And this technique that I'm about to discuss or to give you an idea or that I'm introducing right now is, one of the many methods that you can use to solve a DE. If the given DE is not or it cannot be solved using this method, then it means that you can use a different method or there are other methods or techniques that you can utilize to solve that first order DE. Okay, clear? This is just one method. And not all first order DEs can be solved using separation of variables. Okay, remember that. Not all differential equations can be solved using this method. Okay, so but first, we'll focus on this method. And if, for instance, you will encounter differential equations that cannot be, okay, you cannot be able to separate the variables, then just leave the problem or leave the given DE and don't solve it because you haven't learned yet the other methods. So we'll focus on this one. Now I have here 4 problems that we will be solving, okay, and we will utilize separation of variables. So take a look at the given differential equation. So pag naka-factored form or if the given DE has a coefficient that you can be able to factor or that function represents 2 or a product of two different functions, function of x times function of y, then we can be able to separate the variables. Okay? That's the only way that we can solve the DE. We can be able to put y, this is a dy, and then x with dx. Okay, so your idea here for us to solve, basically, if possible, we put all functions of y, or all y's, this is the left-hand side, and x at the right-hand side. And if it's not possible, so you can actually put the entire, each term, this is the left-hand side, and then equate that to 0. Okay, now let's try example number 1. Okay, so we have dy over dx equals xy. So this is a first order differential equation because this equation contains what? First derivative as, the highest derivative, and there's only one derivative in this equation. So first derivative siya. Then this is a first order differential equation. Now it is equal to, this dy over dx is equal to x over y. Now we can be able to separate this since we can, do cross multiplication. Okay, cross multiply um, y to dy and x to dx. So by doing that, okay, we're able to separate the variables where the left side is a pure function of y and the right hand side is a pure function of x. Then if you can be able to do that, you can now integrate both sides of the equation. Okay, so the next step will be the integration process, or the process of finding the integral. So integral of y dy is y squared over 2, and integral of x dx is x squared over 2. So usually we write the equation into this format where the y function is at the left-hand side and the x function is at the right-hand side. So you can put the arbitrary constant at the right-hand side of the equation, because on the left hand is your unknown or dependent variable. Sa right-hand side is the independent variable. So usually doon ka nag-add. So we add the arbitrary constants at the right-hand side. Okay, kung saan yung independent variable or independent variables mo. Okay, so instead of writing, you can put plus c there, or we can simplify further by putting c over 2. So we're doing this because c represents any value or constant siya, diba? So c could be ln of c, c over 2, 2c. Okay. Now we multiply both sides of the equation by 2. Okay, since we are after simplifying the solution. Now we have y squared equals x squared plus c. Okay, so if you're asked to solve for y, so maybe you can rewrite this solution, but this is acceptable already. So y squared is equal to x squared plus c. Again, solving for y, so you should take the square root of both sides of the equation. Okay. Now we have y squared is equal to x squared plus c. So solving for y, so we take the square root of both sides of the equation. So we have y equals the square root. Yeah, it should be y. Y equals the square root of x squared plus c. So this is now, your final answer. So if you are asked to solve for y, then y is written explicitly. So y is equal to this one. We can have this solution for the DE. Again, just a recall of how to simplify this given solution. If, for instance, you did not put your plus c into this format, so you can always replace your final answer with a plus c. Excuse me. So let me just have this one. So for example, you have, of course, just have to copy this one. So y squared over 2 equals x squared over 2. And then you just, what you did is you put only c. So to simplify this, then you multiply both sides by 2. So you have y squared equals x squared. And then by multiplying the entire equation by 2, so you have 2c. So again, I said that this term right here, yeah, c could represent any value, right? So pwedeng c over 2, pwedeng 2c, square root of c, e raised to c. So you can always, replace that as c in your final answer. But in this example, yeah, prior to, I already, modified, or I have changed the value of c here so that I will no longer change c at my final answer. Okay? So that's, one of the techniques that I have used. So prior to changing the c, so initially I have already changed the value of c. Anyway, so let me just, there are still students who are entering this class. Let me just add them here. Okay, any questions, guys? None? Okay, so I think we can proceed to the next example. Again, the method that we're going to use is separation of variables, okay? Function of x to dx, remember this, function of y to dy. Clear? If you cannot be able to separate the variables, then there are, other techniques or methods that you can use to solve that DE. Okay, another example prior to solving this one. So let me just give you another example here. Wait a moment. I'll just get a pen. Okay, for example, so I have xy plus x, okay, times dx. And then I have minus, okay, x, y, plus y, okay, times dy equal to 0. Okay, this dE is actually in the form m dx plus n dy equal to 0 again. So let's leave this one first. I'm doing a different example for this one, showing you how you can be able to separate the variables if separating the variables is possible for this example. Okay, so looking at the first term here, okay, the question is, can we factor, or can we, since this coefficient here, m, xy plus x, you have both functions of x and y, or the variables x and y here. So the question is, can I be able to factor this? Of course, there's a common factor here, right? So x is common, so you can factor out x, and then you have y plus 1. Naka-product ng dalawang functions. Pure function of x and pure function of y times dx. So second term naman, so you have here x times y plus y. So common factor in each term is, so you have y here, factoring out y, you have x plus 1 times dy equal to 0. So if you can be able to put the equation to this format that you have factored each term, then the possibility of separating the variables is, is really, you can be able to realize, doing the separation of variables. So now is the time to separate the variables. So what you want in the first term is a pure function of x. So what you need to do is to eliminate y plus 1 here. or to remove y plus 1 here. So it means that you have to divide both sides by y plus 1, okay, to remove this function here because you only need pure functions in each term. The second term, you have dy. So this term should only contain variable y. So what you need to do is to remove or eliminate x plus 1. And how can you do that? By dividing both sides by x plus 1. So dividing the entire equation by these factors or by these functions, y plus 1 times x plus 1 will give us, okay, wait a moment. Okay, hello. Oh, sorry for that. No. Go back, go back. Ayan. May mga pumapasok pa kasi sa klase. So next time, if you want to attend the class, be early, okay? If you have problems connecting, then I can consider you accepting in this class. Anyway, let's proceed. Again, reminder, this class is recorded, so you can always, check the recorded class or lecture. Now, going back here, so dividing both sides by these functions. Kita ba? Medyo madilim. Anyhow, so we have now, cancel na to, di ba? So you have x, dx over x plus 1. And then the second term here, gusto nating matanggal yung x plus 1, di ba? So we can cancel x plus 1 in this term. So you have minus y dy over y plus 1 equal to 0. So pure function of x and pure function of y in each term. Now the next step is to integrate this given equation. Okay, so that's the method here on solving a first order differential equation. Now let's proceed to this one. Let's examine this problem. Okay, so 1 plus x dy times dy minus y dx equal to 0. So no problem here, is in factored form already. So we can actually transpose the second term to the right-hand side, making this positive y dx. Okay, now on the right-hand side, it's not a pure function of x. So you need to eliminate y here. On the left-hand side, you have dy, and it's not a pure function of y. So you need to eliminate 1 plus x here. So what you will do is you divide the entire equation by, of course, to eliminate 1 plus x, so divide both sides by 1 plus x. And on the right-hand side, to remove y there, so you divide both sides by y. And giving us, we have dy over y equals dx over 1 plus x. Okay, so what have you noticed? A pure function of y and a pure function of x. Then we can integrate both sides of the equation. So the next challenge will be the integration process. If you forgot how to, perform, or if you forgot some of the techniques in integration, so that will be, a challenge for you to be able to arrive at the final answer. Now, if you remember this formula, so integral of du over u is actually ln of u. So this is actually logarithmic. So ln of y, and the same for the right hand side is ln of 1 plus x. Of course, we put plus c. So just a recall again for, wait a moment, there's a chat here. Okay. Now, let me just solve this one. Okay, so why this term becomes ln of 1 plus x. Yeah, from the formula, okay, du over u, remember, it's actually ln of u, right? So here, our u is this one, the denominator, and then this should be our du. If we differentiate 1 plus x, so this is dx, right? So the formula, integral of du over u, is satisfied and becomes ln of 1 plus x, okay, plus the arbitrary constant c. Okay, now let's continue here. Now, since the most, the left-hand side is ln, the right-hand side is ln, so you can simplify this equation by making, instead of writing c, you can, replace c by ln of c. Okay, so whichever is appropriate that you can be able to simplify the entire equation. Okay, so what I'll do here is, instead of writing c, I'll put plus ln of c. So why put ln of c? And the properties of logarithmic functions, you can combine you can make this into a product form, right? The argument here, 1 plus x, can be combined into one term only, right? So this becomes, if you remember again, so let's just recall this one. Okay, for the properties of logarithmic function, ln of the product of x and y and is equal to ln of x plus ln of y. And another one is ln of x over y can also be written as ln of x, the numerator, minus the ln of the denominator. Okay, so remember these properties. And also, so what's the point here? For me to be able to eliminate the logarithmic function, so you do anti-ln or anti-natural logarithm. Because when we do anti-ln, say for instance, e raised to ln of x, okay, this is anti-ln, so this becomes x, removing the logarithmic function. Okay, when we say e raised to ln of y, this actually is equal to y. So that's the purpose of making this equation na ln na lahat. Okay, so let's proceed. Okay, so what we're doing here is we do anti-ln, e raised to ln of y. And this entire term here, this is actually, we combine them, ln of 1 plus x times c. So becomes one term. So e raised to ln of 1 plus x times c. So that you can be able to do anti-ln both sides. So this becomes, again, so in e raised to ln of y is y, and e raised to ln of x is x. Remember this property. Okay, so we apply it in here. E raised to ln of y is y equals the product of arbitrary constant c times 1 plus x. Okay, so this is now the solution to this first order differential equation. Any question? Questions, guys? None? Okay, walang tanong.
Sir,
We
wait
can
lang, sir. Ako,
yeah.
meron ako. Sir?
Yes, sure.
Bakit nga po ulit naging E yung dito sa next, yung sa taas ng sagot, E loan, raised to loan Y. Bakit naging
Okay.
E nga po ulit yun?
Okay, so as I mentioned earlier, so we must be able to simplify the equation, right? So by doing ln, this is one way of simplifying or removing ln. So to do that, para remove natin yung ln, to remove ln is by introducing the anti-ln or u take the anti-ln of both sides of the equation. Okay? So ln of y, okay, integrating this equation will give us ln of y. And on the right-hand side, you have ln of 1 plus x. Okay, so again, your solution should be simplified. So, and since the dependent variable or the unknown function is not in its simplest form, okay, naka-ln of y siya. So usually our final answers um, are in the solve for y format, or y is written explicitly. You always consider y in simplifying. So if this is not simplified, so you must be able to find a way. So each of the terms have ln already. So you transform this into one term, ln of 1 plus x times c. Now, you can apply now anti-ln on both sides of the equation. So just like, taking the square of both sides, dividing both sides, and yeah, just like that. So e raised to ln of y is equal to e raised to ln. So both sides of the equation, you applied this, technique in simplifying. Again, property of logarithmic functions or anti-ln, e raised to ln of something is equal to something. E raised to ln of something is equal to something. So ganun lang din yung idea.
Sige
Okay?
po,
So
sir. Thank you, sir.
in that way, ano nangyari, we were able to remove the ln na function. Okay? We were able to remove ln. So
So,
that's,
bali, sir, applicable siya as long as lahat ng terms may LN.
yes,
Okay, sir. Thank you.
exactly. Okay, and you should, prior to doing that, you must be able to combine these terms into one term para ma-apply mo siya.
Sige, sir.
Okay?
Thank you.
Just like this, di ba? Kinumbine ko muna sila, naging isang term na lang, right? ln of 1 plus x times c. Yung nga pinakita ko kanina, yung product property ng mismong logarithmic function and the quotient property. Okay? Any more questions? Okay, no questions. Let's proceed to the next example. Okay, the next example is, again, find the general solution of x times y raised to negative 3 dx plus e raised to x squared dy equal to 0. Again, so if you can be able to separate the variables where x ay naka-dx and y is naka-dy, then that d is a separable differential equation and you can integrate the dE. The next step is integration. Okay, by looking at this equation, so we can be able to separate the variables. We can work on this equation sa left-hand side na lang. So instead of transposing this to the right-hand side. Okay, so we'll eliminate on the first term, we need only function of x or pure function of x. So we will divide both sides by y raised to negative 3. And on the second term, you have dy, so you must remove e raised to x squared. Now, what you will do is divide both sides now by these functions. So you have x, x dx, cancel na yung y raised to negative 3. So maging over e raised to x squared plus the second term is, okay, matatanggal na yung e raised to x squared dyan. So you have dy over y raised to minus 3 equal to 0. 0 divided by any function is equal to 0. So this one, a pure function of x, okay, pure function of x na siya, and this term, pure function of y, so we can now integrate each term. Okay, or pwede mo nating, prior to integration, we bring this up. So magbabago lang yung sign. So you have x times e raised to minus x squared times dx. The same with the second term. So you put that sa taas. So magiging y cubed dy, maging positive yung sign equal to 0. Then you apply integration or integrate both sides. Yeah, and so this first term involves exponential functions. So recall the formula for integration or for integrating exponential functions. Remember, integral of e raised to u du is e raised to u, okay, plus the constant, arbitrary constant. Now looking at this given um, integrand, so we have to arrange this one. So e raised to minus x squared times x dx. So let's examine if this x dx is the differential of the exponential function. So as you can see here, wait a moment. Okay, so minus x squared is our u, okay, by referring to this formula. And then differentiating minus x squared, so we have u becomes du. You copy minus sign and then differentiate x squared, so you have 2x dx. So as you noticed, here you have x dx, so you only need minus 2 to be able to satisfy this formula. So you can introduce a neutralizing factor na. So you put minus 2 here. Pwede mong gawin yan, minus 2. And then you put a neutralizing factor na minus 1/2 dun sa labas. Okay? Or you simply utilize, this or substitution. Okay? Or you can say, yeah, remove muna natin yung minus 2. Okay, so what we will do is we solve for x dx. So divide both sides by minus 2. So we have x dx equal to du over minus 2. Now we apply in this formula. So e raised to u du over, of course, you have du over minus 2. Because x dx means du minus du over minus 2. And then here you have a constant. You can actually factor out or put the constant before the integral symbol. So minus 1/2. Integral of e raised to u times du is equal to minus 1/2 e raised to u. But what is u? U is equal to minus x squared, right? So i-plug in mo na dito. So satisfied na yung formula. So we have the integral of x times e raised to minus x squared dx is actually minus 1/2 e raised to, ito yun, e raised to minus x squared. So that's the integral for the first term. Now, for the second term, we have the integral of y cubed dy is using power formula. So y raised to 4 over, okay, so over 4 equal to the arbitrary constancy. Yung nasa right-hand side is the arbitrary constancy. Or pwede mong i-transpose one of the terms itong function of x dun sa left-hand side. So here, what I'm doing here is I'm simplifying the equation since, okay, looking at this one, I have prioritized para ma-simplify natin yung y. Okay, so the y function here has a denominator of 4. So I have based my way of simplifying this equation dun sa function of y. So that's why I have put here c over 4 to remove 4 in this entire equation. So multiplying both sides by 4 will give me, let's just wait for a moment. So I have 4 times negative 1/2 or 4 divided by minus 2 is minus 2. E raised to minus x squared plus the second term will become y raised to 4 equal to c. So, ayan, we're able to simplify, or if you're asked to solve for y, so we will transpose this term to the right-hand side. So it will give us positive 2 e raised to minus x squared. Yung negative dito, naging positive siya nung transpose. Again, this is one way of writing your solution if you're asked to solve for y or to express your answers, in terms of, you have written y explicitly. So plus c. So this may be your final answer, or you can take the fourth root of both sides. So you have, yeah, fourth root of 2 times e raised to minus x squared plus c. So this will be your final answer to the given differential or first order differential equation. Or simply, you can just transpose, you can put this y raised to 4 equals, oh yeah, you can arrange that into this format. Minus 2 e raised to minus x squared equal to c. Can be your final answer too. Okay? Any questions here? Yes, any questions? None? Clear? Okay na? Okay, so silence means yes, no questions. And we can proceed to the next example. Okay, our next example is, okay, we have the problem y times e raised to 2x times dx equals 4 plus e raised to 2x dy. So as you can see, there is an equation here on the left-hand side, and you have, I mean, there's a function here on the left-hand side and on the right-hand side. So what we will do here is, prior to interchanging their positions, we can examine each term here. So dx, this should contain only a variable x or function of x alone, and dy, this should contain only coefficients of functions of function of y alone. So what we will do is we divide both sides by, here to remove y, so you divide both sides by y. And on the right hand side, to remove 4 plus e raised to 2x, is you divide both sides by this function. Now we will interchange their positions. So we have dy over y equals, yeah, you have e raised to 2x times dx over 4 plus e raised to 2x. Now this is a pure function of y, and this is pure function of x. Then we can integrate both sides of the equation. Integral of dy over y is ln of y, and this one right here. So we will examine this given integrand. Recall that integral of du over u is ln of u. So if this denominator 4 plus e raised to 2x is your u, then the numerator should be the du, or it should satisfy the differential, its differential, so that we can be able to use the formula ln of u. Now what I did here is I will differentiate u, this becomes du, and differentiate 4 plus e raised to 2x, differentiate a constant, it's 0. Differentiate e raised to 2x, so just copy this, e raised to 2x, differentiate 2x, and that is 2 dx. So as you can see, the given numerator is actually, or contains e raised to 2x times dx. So what's lacking here, para magamit natin so we can use this formula, is the constant 2. So you can actually have a neutralizing factor na 1/2 to utilize this formula. Okay, so dividing both sides here by 2 so that we can apply this substitution or this formula. So yeah, e raised to 2x dx. Okay, now plugging in here, so e raised to 2x dx is equal to du over 2 all over this denominator is represented by u. So we can actually put the constant before the integral sign, so it's 1/2 times the integral of du over u. Then you can use this formula. The result is ln of u. So 1/2 ln of u. Okay, but what is u? U is equal to 4 plus e raised to 2x. So ganun lang yun. And then you put the arbitrary constant c dun sa right-hand side. So function of x dito, so dito ako magpa-plus c. Now, to simplify or to solve for y, so I mean, our one consideration for simplifying this solution is the state of the function y. So this in ln siya, diba? So we will simplify this equation. We will remove ln, or logarithmic function. So by doing that, we can also put the constant into this form, so ln of c, and then combine this side of the equation into one term only, so that we can use the anti-ln. So this one right here, the coefficient, the 1/2 here, so we put that into an exponent. Okay, so just a recall of this property. So remember, so when we say, if we have this, so a ln of x, for example, so you can actually write this as this coefficient or value here can become the exponent of the argument. So ln of x raised to a. So this property was utilized in this part of your solution. So this 1/2, we have put this as the exponent so that we can combine, okay, this entire, this part of, or this side of the equation. Okay, because you cannot combine these two terms if there are coefficients other than 1. Okay, so it must be 1 coefficient there, so that you can actually apply the idea na ln of x plus ln of y, putting them into one term is actually ln of the product of x and y. So ayan, pwede mong pagsamahin kasi sa isang term lang. Just like this. So yung coefficient dito, or you have here 1/2, so you must be able to remove this one, and then by removing that, you can actually transfer it here as an exponent ng argument mo, and then plus c. Okay, clear? Then let's continue this one. So, ayan, nag-multiply na tayo. So, nag-times c na, utilizing this property. Okay, now what we will do is we take the natural logarithm of the entire equation. So by doing that, so we put e raised to ln of y equals e raised to ln of the product 4 plus e raised to 2x raised to 1/2 times c. So by doing this, we can be able to remove the logarithmic function there, or ln. So naging y equals c times this one is the square root of 4 plus e raised to 2x. Okay, so this is now your final answer. Okay, wait for a moment. I'll just remove this one. Yeah. Okay, any question, guys? This is not your final answer. This is in a form na naka-arrange na yung y mo explicitly, solving for y. Okay, any questions? Clarification? Naintindihan ba? Do you follow?
Opo, sir.
Okay, that's good. Ibig sabihin, naintindihan. Now we can proceed to the next part. Okay, now, how about if you're asked to solve for the initial value problem or obtain the particular solution, or how to obtain a particular solution. So let's have this simple problem, first order DE. So again, so in the previous, examples, we are actually asked to solve for the general solution. Now in this case, you're asked to solve for the particular solution. So you have initial values or initial condition. So here I have dy over dx equals minus x over y. So I'll just cross multiply. So y times dy equals minus x dx. Yeah, very simple lang na kasi separable dE siya. So pure function of y, and the right-hand side is a pure function of x. Now, integrate natin yung left-hand side. So you have y squared over 2 And here, the right-hand side, the integral of this is minus x squared over 2. Of course, you don't forget to write plus c. Since the entire, each of the terms contain, diba, 1/2 or over 2, we can simplify by putting c, you're writing c as c over 2. Okay? And then you multiply both sides by 2, we now have the equation y squared equals minus x squared plus c. Okay, this is now your general solution. Again, a general solution is a solution of a DE having arbitrary constants in it. Okay, so for us to obtain the particular solution, we have to utilize the initial values to solve for this arbitrary constant, and then we plug in the value of C in this general solution for us to obtain the particular solution. Okay, so what we will do here is we'll utilize the condition. So this means that when x is equal to 4, the value of y is minus 3 or negative 3. So ito yung ibig sabihin ng ganitong notation of your initial condition. So what we will do here is we utilize the general solution to find for the value of c. Okay, so we'll plug in now x equal to 4 and y equals to minus 3. So y squared becomes y minus 3 raised to 2 equals minus x squared, which is 4 squared plus c. Okay, so minus 3 squared is just 9. And then here you have minus 4 squared is 16. So plus c. Now c is equal to transpose 16. So we have 9 plus 16 is equal to 25. Okay, so we have now the value of c. And then you plug in c in the general solution, giving us our particular solution will be y squared equals minus x squared plus 25. Okay, or you can actually transpose yung x squared to the left-hand side. You can combine, you can put them into the left-hand side of the equation. So it will give us x squared, positive x squared, plus y squared equal to 25. Yan. So equation ng circle, right? So this is now the particular solution for this given problem. Okay, so that's how you do, okay, or how you solve initial value problems. So prior to arriving at a particular solution, so yung una mo munang solution na, na makukuha is the general solution. It contains the arbitrary constant C. Okay, questions? I think I was able to present na this one last time, diba? How to solve for the particular solution. Well, anyway, that's our topic for today. So I will be having a separate lecture or a discussion, especially that you have your first quiz. So I will have a separate meeting. Maybe we can utilize the other schedule. So I'll invite you if you're available. So the attendance is not really required. So for those who want to, um, if you have questions or clarifications, if you want to know the solution of the quiz, if you have any concerns, so I can have a separate meeting. I'll be announcing that prior to taking the prelim exams. So we'll have a separate session. Okay, so as you know, naman, we are only required one meeting per week. So if you're available for the other meeting, for the next meeting, so pwede na tayong mag-meet to have more problems to solve. Yeah, so we can utilize that meeting for me to be able to address some of your concerns, but it will not be recorded, or kung kaya pa ng aking laptop na tumanggap ng malaking file, so you'll be able to record it. Anyway, so that's my plan for next week. Maybe if everyone has already taken the quiz, then I can be able to show the solution for, yeah, the solution for your quiz. Okay. Yeah, you can ask me, pwede rin namang tanong niyo yung answer for the problem set. So I already checked some of your problem sets. Those who have submitted their problem set, I have already checked. Yeah, especially the problem set, the first problem set. Okay, now I think that's all for today. Do you have any questions or clarifications? Questions, guys? Are you shy? Okay, basta ganun yung idea natin. So next meeting, maybe, or not this week kasi some of you are still taking the quiz. So maybe next week, yeah, we will have 2 meetings. Maybe just 1 meeting. I'll invite all my students in DE. Not kayo umattend, like webinar. Okay, so I will be presenting the solution. So hopefully, so majority of you have taken the quiz next week, although the deadline is, the deadline to take the quiz is October, first week of October. So I'm hoping that you can be able to take the quiz number 1 because you have another quiz coming after my lecture next week. It will be about application of first order. So we will have the first installment of the application. So solving for the growth and decay or population growth and Newton's law of cooling. So those are the first, installment ng application ng DE. Since I have already introduced this, topic, how to solve the DE, and one method is by separating the variables. Okay? So yun lang naman. The first application natin will focus on, okay, elementary lang na application, guys. Okay, so any questions here on separating the variables? Maybe I can give you some ways how to separate. Maybe I can share you this one. Wait a moment. Okay, let me show you my whiteboard. Okay, because here's the thing for your quiz number 2. You will have maybe a number of differential equations, first order differential equations, and not all differential equations that are being written there or being displayed in your screens are separable DE, or it means that some of the DEs there or differential equations are not separable. And you will be asked only to solve for differential equations that are separable. Okay? So you have to practice the skill, okay, on separating the variables. That's why I have presented earlier, how to factor. So you remember, factoring, especially when the given expression contains variables x and y. Okay, so let me just, okay, wait a moment. I'll just check my notes. Okay, if you have a book, yeah, may Rainville, let me just look for some problems that I can present to you. Kasi wala naman kayong tanong eh, di ba? So ako na lang yung... So the possibilities is it will not be focused only on linear equations. So nonlinear equations means, di ba, having some other functions like trigonometric functions, exponential functions, logarithmic functions. So pwedeng involving ganong klaseng functions. Okay? Say for instance, I have this equation. So let me just write x. Naririnig niyo ba ako? Baka nakakatulog na kayo. Can you hear me?
Opo, sir.
Sir.
Okay. So I'm writing this one. Ito lang I will be doing separation of variables. So the rest will be, the next step will be integration na, di ba? So ito lang yung technique na, I will be showing you. Maybe you will realize, Separable pala siya kahit nasabihin mo na parang hindi naman separable 'to. Okay. Ay, wait lang. Parang ang pangit yata ng pagkakasulat ko. Sorry for that. So, liitan na lang natin. So, x times y plus x. Okay. So, this is the dx. And on the right-hand side, you have this expression here. So, you have x squared multiplied to y squared plus, I think you have several terms here, x squared plus, okay, y squared plus 1 times dy. Okay, sa inyo ko lang ito na-presenta sa ibang section, hindi ko pa nagawa to. Anyway, so as you can see, this differential equation contains, diba, functions of x and y. Like dx has a coefficient na not a pure function of x, may y ka dito. So yung idea is, can you be able to separate the variables here? So kung may factored form dyan, or pwede mong i-factor dyan, you factor it. Here naman, you have na, diba, dy, dapat pure function of y lang din, diba? So your goal is to separate the variables. If you can't be able to separate the variables, then this dE is not separable. Okay, I'll be also giving an example of not separable DE, but this one is, I can say this is separable DE because I can be able to factor this. Here, common yung x, right? So you can factor out x. So you have now the factors x times y plus 1. You can open your mics if you want to, join me in simplifying this one. Okay, there are 4 terms, diba? Pwedeng i-group natin to. Factoring by grouping. Okay? So, paano yan, sir? Here, sa first 2 terms, common yung x squared, right? So, you can actually factor out x squared. So, factoring out x squared, we have, anong matitira? Sa first term, you have y squared. Anong matitira dito sa second term? Plus 1. Okay? So, yung 4 terms natin sa side na to ng equation mo becomes dalawang terms na lang. Ito i-group din natin as 1 term. Okay? So, y squared plus 1. Ayan. So, this is now the coefficient of dy. Okay? So, dy initially, di ba, has how many terms na coefficient? 1, 2, 3, 4. We reduce that, by grouping, naging dalawang terms na lang, di ba? Ito, 1, and 2. Right? Dalawang terms. Now, in each term, meron kang nakita dito na y squared plus 1. Diba? There's y squared plus 1, y squared plus 1 here. So, you can factor out y squared plus 1. Follow? So,
Yes, sir.
factoring that, anong matitira sa first term? If nilabas mo yung y squared plus 1, yung matitira is
X squared na
x
lang po.
squared. Yung second term, anong matitira
Plus
dyan?
1.
Plus 1. Okay, so what can you say about the resulting side of the equation? Ito, pure function of x, di ba? Right? Ito, pure function of y. Right? So, separable siya. Kaya natin i-separate yung variables. Okay? So, having written that, ayan, ito, we can actually eliminate what? Y plus 1 dito. Ito naman, we can remove x squared plus 1. Sige, kopyahin na lang natin. So the equation actually here, I don't know if this is part of your problem set. So again, you have another problem set coming up if you have checked your, anyway, so does everyone here were able to, was able to check their M rooms or my LPU? Do you have any problems or? with your my LPU. Ito, we will remove what? Y plus 1. Okay? So we divide both sides by y plus 1. Here we will remove what? X squared plus 1. Okay? Then we have the resulting equation, a pure function of x. Okay? Over what? Ito? So magiging x dx to over, tanggal na yung y plus 1, right? So matitira is x
X
squared
squared.
plus
1.
1. As you can see, pure function of x na siya. On the right-hand side naman, so meron kang y squared plus 1. Diba? And dividing both sides by these factors, ayan, will give us, makakancel natin yung x squared plus 1. So matitira is y plus 1. So ayan na, we were able to separate the variables, a pure function of x, so pwedeng integrate natin to a pure function of y. So the challenge now is for the integration naman, di ba? Sa technique ng integration. If you forgot how to integrate, then that will be, you will find it hard to arrive at the general solution of that given DE. Okay, so that's the next step. So you integrate. Ganun lang. Now, I'll be showing an example of course, not separable. So, ano mga example ng not separable? Maybe I can, for example, ito, x squared plus y squared. Pag hindi siya factorable, you cannot be able to, plus x minus y dy equal to 0. Okay. So again, can you separate the variables here? Pag may plus kasi, di ba? So kung may common factor ba sa kanila? Wala. Right? Ito naman, x minus y. So this one is a not separable. Okay? Do you follow, guys? Not separable. Ano pa mga example? But if for cases like, ito kunyari, pag naging minus to, tapos ito, 1 na lang. Separable ba? Hindi pa rin, no? Not separable. Because yung factored form nito is x minus y times x plus y. And this is not a pure function of y kasi may x pa rin dito. Not a pure function of x because may y pa rin dito. So, not separable pa din siya. Okay? So, careful. Okay? So, maybe there are functions. Okay, how about this one? I will be e raised to x plus y times dx, dy over dx equal to minus 2. Okay, how about this problem? Ayan, pinapakita ko na yung mga ano ko. Sa inyo lang to. So hopefully the other sections will watch this video. Okay, invite the other sections to watch this video. Maybe I I forgot to. I can't be able to present this one to them. Okay, so how about this one? Separable ba siya? You think this is not separable. Okay? Pero, separable pala siya. Paano, sir? How come na naging separable siya? Okay. Did you know that, diba, e raised to x plus y is equal yan sa
X
e
plus
raised to x times exponential, diba? Law of exponents. Why? Oh, diba? Do you remember that?
Opo, opo.
So, having replaced this one by itong form natin, yung property ng exponential functions, we can be able to separate, di ba? Akala mo, hindi siya separable, but this is actually separable DE. So, careful kayo. So, you might miss one of the problems dun sa quiz. So, you can separate this one. So, e raised to x times e raised to y. Ayan. So, dy over dx equal to, sorry for that, dx equal to minus 2. So dy, ayan, kailangan function of y lang nandyan. So tanggalin mo yung e raised to x. So divide both sides. You multiply both sides by dx. So you can remove dx here. Ayan. And then divide both sides by, you remove e raised to x. Okay, so you now have, ayan. So left-hand side, you have e raised to y times
dy.
dy. Okay. And on the right-hand side, you have minus 2, ano guys? Dx, yan, over,
E
or
raised to
pwede
x.
mong itaas yan, di ba? Pag tinaas mo yan, magbabago na yung sign. So, e raised to minus x, right? Yung formula lang ng exponential functions, you can now integrate this one, both sides of the equation. That's it. Okay? Ano pa ba? Wala na, no? Sige. Kung meron man kayong ma-encounter, so you can actually ask me. Huwag kayong mahiya magtanong kasi para rin naman sa inyo yan. It's for your own good for you to be able to master differential equations. Okay. Yung D itself is not really difficult. Yung sa ibang techniques na, yung mga integration, yung foundation ninyo with, your idea about trigonometric identities, geometry. So yun yung nagpapahirap dito, yung mga challenges dito. If you're not really, if you have not really grasped or those topics when you have taken them during your first year. Okay, so I think that's all for today. If you have no questions, then we can have our class photo for my report for today. Okay, so I request everyone to please show your faces if you have cameras so I can see you. And let's have a group photo.
Lipat lang akong, sir, cellphone.
Okay, so I'll stop the recording now. Anyway.